Okay, question 3 then. Here is our reaction, and the first question is asking us to see whether the particular mixture it describes here is at equilibrium. So we need our expression for the equilibrium constant, and in this question we're asked about Kc again, not Kp. So looking at that, you can see again they're all gases. So yes, we've got water in it, but it's steam, it's not water being a solvent, so we're not going to leave it out of the equilibrium. So we just follow the normal rules. We've got ethanol on the right, and we've got ethene and steam on the left. So it's a nice simple Kc expression. It's just that. And all we've got to do is to take these amounts that it gives us, turn them into concentrations, because remember the square brackets are concentrations, not just numbers of moles. So we've got to turn them into concentrations first, and then plug them into that expression. So we can just find those 3 values. And that's easy because the volume is 10 dm cubed, so all we've got to do is to divide each of the numbers of moles it gives us by 10 to get the numbers to feed in there. So it tells us that we have 5 moles of ethene, so that will be 0.5 moles per dm cubed, just dividing by 10. The steam, it tells us we had 0.64 moles, so that will be 0.064 moles per dm cubed. And the ethanol, it told us that we had 1.5 moles of ethanol, so that will be 0.15 moles per dm cubed, and we just plug those numbers in. So we've got that ethanol divided by ethene and steam is equal to 0.150 divided by 0.500 times 0.064. And if you work that out, that comes to 4.7 is the number. The units you can work out in the normal way, but actually you don't have to because it's already given you that in the question, is moles to the -1 dm cubed. And the point is that that is not equal to Kc. That would be equal to Kc if it was at equilibrium, but the point of the question is that that's not equal to Kc because it tells you that Kc is 0.13 moles to the -1 dm cubed. It's not equal to that, and so you have to explain that that means that it's not at equilibrium. Okay, and you should write that down. You shouldn't just say this does not equal Kc, because the question said show that it's not at equilibrium. So you have to explain that it's the very fact that this doesn't equal Kc that tells you it's not at equilibrium. So it's spelling it out all the time, not leaving the examiner to figure it out for themselves. Okay, so we work out that ratio. It should be equal to 0.13, but it's not. And the reason it's not is because this mixture isn't at equilibrium. So then it says, okay, so which direction will the reaction go in order to reach equilibrium? And now we look at the fact that 4.7, we can say more than just that it's not equal to 0.13, it's bigger than 0.13. So that's what we say, that 4.7 is bigger than Kc. And then we do top line, bottom line thinking. That's the key thing. If the answer is bigger, that means that the top line is too big and the bottom line is too small. So we can say that, spell it out like that, and say that's what we can deduce from this number being bigger than 0.13. It means the top line is too big, and that means we've got too much of the stuff on the right. In other words, we've got too much ethanol. So in order to bring it into line with Kc, it's got to go to the left. Okay, so the reaction will go to the left, or go in the backward direction. So that the value reaches Kc. And once it does reach Kc, we'll have reached our equilibrium. Okay, so again, spell it out. explain the starting point is that because the value we've calculated here is bigger than Kc, that means the top line is too big, and that means that we need less of the stuff on the right, so it's got to go in the backward direction in order to bring that line, that value into line with Kc. Once we've done that, we've reached equilibrium, so that's the answer to part A. Part B is asking us what happens to the amount of ethanol in the mixture if we decrease the total pressure. Okay, so the question is, if the pressure goes down, what happens to the concentration, or rather the amount of ethanol in the mixture? So that's what we're aiming to answer. Now, if it just said that, the easy way to do that, and the way you should do it because it's quick and reliable, is to use Le Chatelier. And he would say, of course, that if you decrease the pressure, it will shift in the direction that tries to increase it again. In other words, it will shift to the left because there are more moles of gas on the left, and therefore the amount of ethanol would decrease. But if you wrote that, you would get no marks, because it says specifically that you have to explain in terms of Kc, and that means Le Chatelier arguments are not allowed. So that's your Kc expression, and it's about doing top line, bottom line thinking. What's going to happen to those concentrations when we change the pressure? What will that do to the value of the expression, and what does it therefore need to do to stay in line with Kc? That's the way to approach these questions. So the first statement to make is that Kc will not change when we change the pressure, because the temperature is still the same. Remember that temperature is the only thing that affects the value of Kc. And you need to say that explicitly. You can't just imply it. It needs to be absolutely crystal clear that you know that the value of Kc will not change because the temperature is unchanged. So say that first. And then you say, right, okay, what's going to happen to these concentrations? Well, in general terms, you know that if you decrease the pressure, it means the particles become more spread out. In other words, the concentrations decrease. So that's the next thing to say. Okay, is that the pressure decrease will decrease the concentrations. Okay, so you've got to be clear about that, but that's just a simple picture of the molecules makes you realise that that's going to be true. And then you think, okay, well, what's that going to do to the top line and the bottom line? And the point is that you've got concentration squared on the bottom line, so each of those terms is going to be decreased, and that's going to give you a bigger overall effect than just having the one concentration on the bottom line. So that's the next point you make, is that this decreases the bottom line more than the top line. Because there's a higher power of concentration on the bottom. Okay, and it's worth really spelling it out like that, so that everyone, including yourself, is clear that you've really thought this through. Higher power of concentration on the bottom. So what does that mean? Well, if they've both decreased, but the bottom line has decreased more, it means in effect you're now dividing by a smaller number. And if you divide by a smaller number, the answer gets bigger. So that means that the expression value gets bigger, and so is now bigger than Kc. And now we're almost there, because you then just say, so what has to happen in order to get back to Kc? Well, we've got to decrease the value. And how do we do that? Well, we shift to the left. Okay, because if we shift to the left, it decreases the top line and increases the bottom line. So that's what we need to say then, that it will shift to the left to make the top line smaller and the bottom line bigger. And hence return to Kc. Now you have to be careful, because you haven't quite finished answering the question yet, because the original question was what happened to the amount of ethanol. So your final conclusion, which we'll just put up here because we're running out of space, is that the amount of ethanol increases. Because if we shifted, decreases, try and get that the right way around, the amount of ethanol decreases because we've shifted to the left. And that's the answer. Part C is asking us about catalysis of this reaction. First of all, it just says what catalyst is normally used. So this is just knowledge from first year chemistry. Hydration of an alkene, the catalyst is phosphoric acid, would be the best answer. You would also, I think, be allowed concentrated sulfuric acid, which would also work, but that's the one that you should have learnt. So if you didn't know that, that's probably a good sign that a bit of first year revision would be a good plan. And then it says, what effect does that catalyst have on the position of equilibrium and on the value of Kc? So make sure you answer both parts of that question, and the answer is no effect at all. Remember, what catalysts do is they increase the rate of reaction, but when you have a reversible reaction, you get effects on the forward and the back reaction where they're increased in rate by the same factor, and therefore the position of equilibrium doesn't change, and nor does the value of Kc. So you need to say both of them are unaffected.